Well, if you saw my last video, you saw this voltage-controlled oscillator that I built. I still have a plan for this oscillator, but in the meantime, I got two fresh, brand new oscillator boards and some higher quality components. I also got this front panel, which I designed and ordered from Front Panel Express. I really like Front Panel Express. You basically just download their CAD program, design your panel, and they mill it and engrave it for you. On the bottom, I've got spots for 3.5mm phone jacks with the outputs in orange and the inputs in white. And on the top, I've got space for two oscillator modules, oscillator A and oscillator B. I decided to call this project Gemini because most of my modules will have a twin module concept. I also got these potentiometers. I like these because they're very small, so you can easily fit a lot of them on one panel. And they also have the knob built in, which makes construction a little easier. Each one also has a little detented switch, so you can turn them on and off completely if you want, which is nice if you want to do some precision voltage control. I also got these very cool retro-looking panel mount red LED indicators. So let's put this thing together. I've got both boards built and fully constructed into the module here. I've got the ramp wave output patched into the speaker, so let's try it out. I also added 6 LEDs to the channel to indicate when there's a control voltage signal, either on the frequency control or pulse width modulation control, or when oscillator sync is being used. Those don't work yet because I haven't built the additional driver circuitry to operate those LEDs. That'll require an additional board, which I have yet to design. In order to mount the PCBs to the panel, I used these right angle brackets, which I got from SparkFun. Each bracket has a threaded side, which I use to screw to the board, and an unthreaded side, which I attach to the panel using some generic cyanoacrylate adhesive. I had to desolder some other potentiometers that I was using for testing, and in the process of doing that, I ended up damaging some of the solder pads on the board. So when I replaced the pots, I ended up having to just run those wires through and solder them to wherever the traces would go anyway on that board. I was able to trace them out, and amazing to me anyway, it actually worked. The ramp wave output looks really good. It's a nice clean signal, and it has excellent response throughout the full frequency range. This is the triangle wave output, and as you can see, it does not actually look like a triangle. In fact, it just seems to be generating a reverse of the ramp wave, or a sawtooth wave. I'm not sure why that's occurring, if I made a mistake somewhere or if I have a wrong component value. I noticed this on both oscillators, and a consequence of it is that the sine wave also looks wrong. Here's the sine wave output, and then you can see, like the triangle wave, it's really only showing half the waveform. These two waves are related. One is built on a filter from the other, although I forget which direction they go in. So I'm sure if I could track down whatever problem is causing one of these waveforms to be incorrect, it would also fix the other one. But my knowledge of analog electronics is basically nothing, so I wouldn't even know where to begin looking. So I look forward to any comments from you guys if you have any ideas about how to debug this problem. The pulse wave output works really well. I can adjust the pulse width modulation to go from about a 95% duty cycle all the way to around 5 or 10%. Here I'm using the ramp wave output of the bottom oscillator to modulate the pulse width of the top oscillator. And here I'm using the ramp wave output of the bottom oscillator to modulate the frequency of the ramp wave on the top oscillator. So overall, I'm really pleased with how things came out. The front panel from Front Panel Express looks absolutely amazing, and the oscillators, despite the fact with the triangle wave and sine wave, sound really incredible, and the modulation works, which I'm really excited about. So I'm about 98% pleased with this. If I can track down the problems with the triangle and sine wave, I'll be 100% pleased. So stay tuned, more videos to come. My next project is going to be the dual MFOS low frequency oscillator.